thanks for making it out in the rain. This is going to be interesting, actually, for the switching of slides. Cool. Make shadow puppets. Okay, so my name is Colin. I'm the director of platform. I shortened it on the slide at littleBits, and what that means is I am responsible for the software and platform that integrates the hardware platform of littleBits and the software dimension that multiplies the capabilities of it. So, and I've come today to talk to you about hardware-software teams and integration that has to happen. So there's a catchy title. There's a formula for academic papers and talks and presentations and stuff that goes into formula, like you get a catchy title, colon, and then the politics of something subtitle. So I wanted to use this. I rarely, as a technology leader in a fast-growing tech startup in New York City, I rarely get the chance to kind of reflect at a meta level. I actually have a degree in cultural studies and cultural theory, and it rarely kind of comes up in everyday conversation when I'm talking about architecture and stuff. So my influences and stuff in my 20s as I was growing up were not the Alan Kays and the more kind of computer science theorists and stuff. It was more like the Alan Watts or Michel Foucault, Derrida, Deleuze, this kind of thing. And all of my thinking and education basically is more around like cultural studies and how people interact and ideologies and stuff. So it's oh, it's under here. Cool. Okay, cool. So yeah, it's less of this kind of world and more of this kind of world. And I kind of came to technology in a roundabout kind of way, around 15 years ago, a little more. And I've seen a lot of stuff, and the fundamentals of kind of this cultural theory has helped me a lot, because it turns out that technology, to a larger extent, is more cultural than technical, actually. There's way more that goes on that is about technology choices, that is about philosophies, that is about our underlying assumptions, that is about aesthetics, all this kind of stuff, than it is about actual technical decisions and like which is the best way to do something. So it turns out that my job as a technology leader has been as much about cultural alignment and ambassadorship between peoples than it has about, you know, getting code written, shipping product, all this kind of stuff. So take it littleBits, the kind of things that we've done at littleBits. So littleBits is on a mission to democratize hardware. That's the stated mission around breaking down technology into understandable pieces and allow everyone to create inventions. It's based around our library of electronic building blocks snapped together with magnets. It's a very satisfying feeling to snap together with magnets the littleBits. If you've never done it, you should go. We have a pop-up shop in Soho right now. And basically this is what the library looks like. So there's an expanding library, ideally infinitely expanding. We have more than 70 different modules, each with a really specific function. Lights, sensors, motors, switches, interaction. There's a branch of analog audio synthesis. There's a branch of wireless, logic, analog logic gates. And then the guy in the middle here is kind of my baby, that is the cloud bit, and it's a Wi-Fi connected littleBits that is the bridge between the hardware library and the modular hardware world and the cloud, of which I am director, it turns out. And that provides this interface and a way that the hardware tabletop experience gets multiplied by everything you can do with software. So in the cloud-bit world, there is we have an immediate control user interface that allows kind of direct real-time control, readout, this kind of stuff. We have an IFT channel that allows interaction with over 200 different web services, hardware services, all this kind of stuff. And of course, it's all, on our side, is all API driven, and we provide access so you have an immediate API integration between the hardware and software worlds. So, what was this back to the title? What is Mushware? I don't know. I couldn't really find a good word to describe what I'm talking about. It's not super catchy. Like, really, Mushware? I don't know. What are you talking about? What I'm talking about is this. First, there's this expression. Anyone, you being the hardware, you've come to hate this expression as much as I have, right? So hardware is hard, right? That means that software is easy, right? Who here thinks, who here writes software for a living? Is this like a software developer more? We have, okay, who here's a hardware developer? We'll actually go some, okay, you got it, okay, a little bit. Just one, we're talking about, you know, intercultural exchange. Anyway, so software is easy, right? It's super, no problem. And there is growing in the world today, and I've been experiencing over the past few years, and growing in more and more places, there's this stuff that is about the intersection of hardware and software. What is this? Is it hard? Is it soft? Is it easy? Is it just kind of mushy? I'm trying to talk about the between soft and firm. I was trying to figure out what is the right metaphor of like, is between soft and firm, I don't know. Please tweet me later if you have a better word for it. But a little bit, we have, I'm going to divide them into pretty specific camps. There's a hardware firmware team that comes from electrical engineering, electronic design, a PCB layout, manufacturing support. They do the parts, choosing parts and all that kind of stuff. They do up in the stack firmware and embedded software, and then we have this other world that has been colliding with the first world around, that comes way more from web software. I myself come much more from web and software, cloud services, APIs, the front-end, back-end stuff, UIs, cross-platform UIs. So we have these kind of two camps, and they have to talk. We have a product that needs to be the seamless integration of these two worlds. So let me take you back for a minute here. In 2008, I picked 2008 because it kind of seems like a good milestone, where we have the full stack. You have this, you know, the front and the back. This is, wow. If you can do front end and back end, wow. You are like enormous, you know, like you've really done something. But now in 2015, this could have been 2013, but I'll say 2015 because it's 2015. The stack is multiplied a lot more. So we have here at the top end, this is like the old full stack. It's starting to look a little quaint compared to all the rest of the other stuff that we're doing now in an integrated system of electronic hardware and firmware, or whether that firmware is on small, you know, 8-bit micros, or whether that's embedded Linux, which is already starting to blur the software hardware lines. And then which is our hardware team does this kind of stuff. And then the thing in the middle is this Mush. I'm calling it the Mush. And it turns out that has a lot of cultural differences that we need to bridge in order that we come up with technological solutions that are the foundation of products and platforms and cool things that people like to do. So, for example, in working processes, on the software world, this is all you folks. You're familiar with stuff, TDD, test-driven development, BDD, spec-driven, the agile stuff. It's all based on the idea of infinite iteration. As soon as you write a spec, it's out of date because somebody wants to change their mind, or you've learned something more from the market. You're always changing. It's infinite iteration forever. And hardware is basically the opposite. It's not agile at all. You get to do one thing, it takes a really, really long time, and you never get to change it ever, for one. Second, if we have this idea, you can never write a spec, it's always evolving and stuff. They very much have the practical viewpoint that why are we arguing about the spec? Don't TDD, BDD, something different development. Just fucking develop it. I made this up. I just fucking develop it. You know what it is. Just make it. You got to get it out there. Someone will play with it. They'll test it. It's good. You put it out because you can't change it anyway. So this is like a really, really big working process as we try and figure out protocols, as we try and figure out how things talk. There's a lot of like. There's a lot to bridge, basically. In technology paradigms and technology choices and how we do stuff. In software, it's all about the nicest abstractions. It for sure is always assuming that computing power is free and cheap and easy and getting infinite. We do a lot of philosophizing about the perfect abstraction to encompass the largest amount of possible futures, and taking for granted basically a lot of stuff about resources, a lot of stuff about our abilities to be infinite, with infinite iteration, infinite resources. On the hardware side, it's all about simplest is best. It's all about really physical limits, like literally the limits of physics on small things. There's like cost consideration. I go to the hardware team, be like, can we do this thing? You're like, well, that's going to cost 2 cents more on the BOM. Like, no. Like, what do you mean 2 cents? Are you crazy? But yes, it's all about this. So then the philosophy is all much more this kind of the Jersey style. I didn't make this up. This is a thing, like the Jersey style. Worse is better. Like the simplest, I didn't want to put dumbest on the slide, but like literally the dumbest way you can do it, for sure it's the best. There are, I don't know if anyone here written any C ever, or like outside of school? A couple people outside of school, you know, like you got nothing, right? You got nothing, and like the ugliest code is always the most performant. It's always the best way to do it. So this kind of stuff, it's always we're arguing about these kinds of things, and even in communication, we have the web team, we tend to be, half of the web team is, or the software team is remote anyway, and the other half will just like to stay home and hang out. Hang out, it's like, it's the same. You have a meeting, you can hang out, you can be there, it doesn't matter. Always like chatting and slacking at like 1,000,000 miles a minute, and a lot of verbose explanations and all this kind of stuff, where the hardware team, like our hardware team literally refuses to go on Slack or any chat platforms. They're like, if you're not in the room, you can come in and hang out, you can pretend to be there, but you were not actually there. It didn't actually happen. A lot of stuff about the values of brevity and really simplistic clarity over like exhaustively covering all angles kind of stuff. So these kinds of things are really, really different paradigms too that we always basically have to deal with. So then, what do we do with this? Why? Okay, you see where I'm going with all this stuff. I'm kind of, dividing the world into two extremes, and then how we do this kind of, how we make it work. What's the next thing? The one metaphor, I like metaphors a lot. The one metaphor I like to think about is treating different teams as you think about APIs. So you have to decide on what you have to agree on in communication, and the rest, please let it be a black box. Like, we don't have to communicate the same. We identify the touch points that are necessary and obscure the implementation of how people are going to work. Fine, you don't want to go on Slack, don't go on Slack, it's fine. As long as we're clear about the kind of touch points and the thing we do have to agree on. So that's really, that was an interesting kind of revelation where we're like, we don't all have to work together, we just have to be divided in smart ways and integrate as APIs integrate. Another thing that is really clear is about identifying what you do have in common and strengthening those. So we can fill volumes with the things that the different teams are going to agree on, even within software teams. For sure, you're going to all have disagreements, and you always have to come to consensus on, there's 20 things we disagree on. Is there that one thing that we agree on, and can we like put everything in there? We did it, it turns out it's not like, it won't be revolutionary to you guys, but it turns out the only productivity tool that the hardware team agrees with the software teams about is GitHub. So just everything always goes on GitHub, where before there would be 5 other choices of places to put it, Google Docs, other spec document, official, like everything is on GitHub and wikis, and everything is on GitHub. Because we agreed on that, that's what we're doing, we just don't have to think of it anymore. So that can like extrapolate into other disagreements and other things you get to agree on. Another thing that we've done is kind of find a third ground. This team is like, for sure this is the best. This team is like, for sure this is the best. Pick a third thing that everyone can like, okay, yeah, I can get behind that. And it sounds like a kind of a lame compromise, but it's actually really cool. So example, we have a lot of the cloud services or Node.js, which half of the hardware team doesn't actually agree is a programming language even, let alone that we should do things in it that go in production. And then on the other half, like of the software team, literally will not recognize C or be able to even understand what is going on. Like I myself have learned a lot, some code reviews of firmware over the past few years. So when we're going to way that we can talk together, like hardware team has to mock out software service, cloud services, the software team has to make choices that are beyond Node.js for other reasons I won't go into in this talk. I have another talk about that. But we pick something. We can go into, I don't know, what are we going to do? We want to start pushing out other services in other languages and stuff. Someone wants Haskell. Someone else is like, I look at Haskell, it makes my eyes bleed. Someone like, etc. etc. You can pick, someone is like Ruby, it's not 2008, forget it, this and that. And then so a thing that everyone can kind of get behind, from infrastructure teams to and DevOps and stuff. Hardware team is actually interested in going with it because it's really, really simple. And so some of the stuff we're doing now is in Go because it is like kind of this like, it's not perfect, but it's interesting enough to everyone that everyone can kind of collaborate, and it will populate cross-team collaboration. We can all kind of look at some stuff in Go, and it's kind of like C, so the hardware team like it, and it's simple for the software. Anyway, it's interesting. So just like compromise, it doesn't have to be a everyone lose kind of situation. It can be good. And then the main point of all of this is about stretching. First, being like more sensitive, less technical and belligerent to engineers, and more sensitive to that someone's technical arguments are not actually technical, they're completely ideological, and understanding where they're coming from and why they're talking about it. Like, yes, there is technical truths to it, but there's always 20 technical truths to any given case, so realizing that it's that. And then I like very much the idea that collaboration, it's not stretching. If everyone meets in the middle, there's no overlap at all. Like if both parts, you meet in the middle, you can't make anything strong on that. Everyone, you can extrapolate this to your personal lives if you want, but it's very, like everyone has to feel like they're stretching uncomfortably in order for there to be enough of an overlap to have a good grip or to build a solid thing on. Like everyone has to be compromising and stretching, and for example, firmware people are like, I'm putting in so much extra stack and software to support a protocol that is super uncomfortable for me, and software people are like, but this is like not even abstracted at all, this is like so raw. And everyone has to feel a little bit of that stretch and discomfort in order that we're going to have enough of a thing to build a collaboration on. Because at the end of the day, it's about collaborating, it's about making something awesome, and it's about bridging cultures in order to go somewhere. So it's interesting to me to have seen a lot of this in the past few years at littleBits.
Yeah, 5 minutes for Q&A, so feel free to shout them out if you've got them. I guess one question I had is, have you what's a time that you've had to work through like a hardware disaster? Can you talk about that?
Disaster? No disasters. Never. Disaster? No, that doesn't happen. Like a hardware disaster. Not a disaster, but a big challenging thing that we did once in the hardware world. We actually, in the cloud bit, we made a first version of it that was entirely different. And it took a long time to do the hardware and the firmware and to work out all of this stuff I'm telling you, because it was new to everyone basically. How we're going to integrate this stuff when we're building everything from scratch. It's very fun. Everyone has a ton of experience, but experience is only worth like half of the battle in any even situation, no matter how much you have. So we're doing a lot of stuff. We took a long time, built this. The module, it worked really great, and it was awesome. And then basically we're like, went back to the drawing board and we're like, you know what, we can cut the price of this thing in half if we do this entirely other thing. Which is, instead of using a hardware module on board that had a lot of stuff in it, we basically took it all down, got a radio that is a USB dongle, and put it in embedded Linux on the chip, and did everything entirely, rewrote the whole hardware thing from scratch, which is then took another. It was like building a custom, like a kernel, and all of it was pretty crazy mix of hardware and software on the hardware and stuff. And the cool thing was then we had, because, that's the beauty of API, because we had already agreed on a lot of these stuff and we didn't have to change the cloud stuff at all, we just kind of switched out. We had to bump a few things of the interfaces where we couldn't control stuff on the first version, and now we got full control and got to make everything simpler. So we had a few changes, getting into API versioning between the hardware and our cloud and stuff, but there was a big rebuild to get it's basically the worst situation in any engineering where you're ton of work in engineering for no user-facing features, but except for the price, which is really, really important in hardware, obviously, because then we get to people actually get to buy it, which is important.
And as your business has grown, do you find you're writing more or less bare metal code, like firmware code? than you were in the early days?
Bare metal, less. Because, I mean, more, okay, so as a library, littleBits started as just very simple analog electronics. So any raw component of sensors or motors or anything you can imagine just getting putting a bit on it and putting the bit snaps, the metallic connectors, and snap it and do that kind of stuff. But there's not that many kind of building blocks in electronics. There's like different kind of sensors, everything based on voltage sensing, and like, I don't know, there's photo sensors, temperature sensors, there's a bunch of stuff, but like once we get the basics of all the analog electronics, everything basically becomes something smarter and something that needs processing power and something that needs, so we still have ones that have microprocessors, but it starts to get to that everything wants a computer on it. And we are not always in the business of putting a computer on everything, because then everything costs a lot of money. There's a lot of actually, we like to think that they came in the wake of stuff that we have been doing for years, but for sure there's a lot of modular electronic kind of, DIY or educational kind of solutions, but usually a lot of them have, each one is super expensive because it has a computer on it, it has wireless communication, it has all this smart stuff, and we want everything to be cheap enough that you can get a bunch of them, because the fun of it and the power of it is, really a modular system. So like, yes, for sure we're starting to do much more like complex computer stuff. We'll get there.
Cool.
Yeah.
Because you're an interesting mix of hardware and software, and you got to get the teams to work together. Do you ask different types of questions during the interview process or the screening process?
Oh, for sure.
Give me an example.
I mean, they're entirely different.
I think you would look at different from a pure software company or pure hardware company. I
mean, the simple answer is they're even like a bit they're even pretty like separated into teams. So for sure, even if we're hiring more software on an embedded side, if it's in a hardware team, you have to understand hardware, you have to understand electricity, you have to understand a ton of stuff about electrical engineering that like I personally don't know, and all the other, like there's a couple of guys here from littleBits, they don't know anything about ohms and resistors or anything, or they know about systems, and it's hilarious that the amount of obscuring of knowledge, like I think some of the electrical engineering side thinks it's ridiculous that we're writing code up here that's so abstracted from what's going on, but it's still very dependent on just like voltages running through the wire. That's all it is anyway. And it's a lot of them find it hilarious that like we understand this like really, really thin layer at the very top and don't even care to understand the like, I was going to say decades, but like hundreds of years of human knowledge that got us up here, and we like don't care. But on the other side, and that's fine for me, that's fine, like that is a different level of expertise, a different type of expertise and different types of things. I don't need to know about that, I don't need to know how my car is made, I just need to know how to drive it. But I'm a hardware mechanic, like he's got to know how the car works, he's got to understand a whole different set of things. We actually have a few people that know that can do this whole thing, which is pretty crazy actually, like literally like build the hardware, lay out boards and put parts and do all this stuff, assembly, and then make like, I don't know, there's one guy made like a radio protocol and then made an app of iOS and Android that will like talk to it and do all this crazy, like as a research project. Like it's pretty crazy the breadth of some people's knowledge. Not everyone has to know that. It's more about like we need people here, we need people here, we need people here. It's more specific. But yeah, the interview process definitely then is like, it's as different as if you're going to have whatever different types of skills you need, whatever you're gonna, you don't have to know about supply chain if you're in sales, et cetera, et cetera. It almost becomes like that. We grow a lot, like we're now over 100 people, so now the specialization is, now we get to specialize, we get to have like real experts in domains. So for sure it's very different.
Since you have two teams with such different perspectives, how do you keep them aligned on like what the goal is or what you're actually really trying to do with something?
That I mean, there's a simple answer and a complicated. I'll do the simple answer. The simple answer is just like you gotta have good leadership, and at the top of product roadmap, like what are we actually trying to do? All the, from tech lead to product manager to everything has to always be like, I do this all the time of like just pulling people out of the weeds, like, oh, yes, it's cool, but like what are we trying to do here? You need to have enough stewards of that kind of stuff. And we have, that's actually, back to your question, for me that's always a really, really clear interview or question, or really, it's hard to ask as a question in an interview, but it's a really, really core value of like, can this engineer understand like really why we're doing what we're doing? That's something that we really look for. We have a lot of really, really amazing engineering talent that is really focused on user experience. It's really focused on product and like why we're doing what we're doing. It's just about, everything I'm talking about is about like observation, analysis, and just being deliberate about stuff, like being deliberate about when you don't have to argue about something, be deliberate about when you stay in this room for 3 hours until you argue until you agree on something, when this person doesn't have to care or know what is the big picture, and when everyone has to really see the goal and be driving towards it together kind of thing. So it's really about alignment and leadership.
Awesome. All right, thank you very much. Great.
Cheers.
All right, so we're going to DAV.
Oh yeah.
And I'm going to invite up Spencer Kuehl, who's the founder and CEO of Cockroach Labs, which is, depending on who you ask, either the worst or the best name for a startup. But then once people find out what the database does, then it becomes the best name. And we are, incidentally, we're proud backers of Spencer's company. I feel like adding that legal disclaimer, but there you go. So you got the mic and you're all set?
I think so. Does it work? Yeesh. All right. This appears to be working. Great. So I don't know how many of you know what Cockroach is. Probably some of you. Maybe a show of hands might be useful. Yeah, so a few.
Yeah, insect, what are you talking about?
So I didn't hear the question.
What's an insect or cockroach to that?
I'm sure you all know what a cockroach insect is. You live in New York City. We're definitely a New York City-based company, so the name makes a lot of sense from that perspective. I'll have a short overview of what the database is, but I don't want to go into too much about like what it is. And since this is an engineering audience, I'd like to talk a little bit about how we do what we do and why that's different from the other things that are out there in the ecosystem. So just in case you're wondering, we did call it Cockroach because one of its chief characteristics is that it's supposed to be very hard to kill. And you know what it is, this is just the shortest slide here. It's a scale-out SQL database. And it's a survivable one, very hard to kill. And crucially, it's consistent. So it's transactional, of course. It's also strongly consistent across wide areas, which is how it gets its survivability characteristics. And the last point on here is, you know, almost as important as the others. It's deployable, and it's deployable with what I think people are starting to consider the new way of doing things for the future, which is, you know, in containers, in public cloud infrastructure. So an overview of the architecture here, and it's quite simplified, but these are the pieces I'm going to talk about in the rest of the slides here. So we implement everything as a set of layered abstractions, and this is crucial because the system is pretty complex. And the layers allow us to treat, from the higher level, things below us as black boxes that provide functionality. And at the lower levels, we can just ignore everything above us. So this is pretty important, and we try not to break those abstractions. So I have SQL up here as the top, and it's on top of this transactional key value layer. SQL is really just the starting point, and the transactional key value layer is really going to give us a base upon which we can build other kinds of database personas. So I have SQL, and also you could do a graph database if you wanted to. So relational or graph, you could even do a document store if that's what you wanted to do. So it's really just the starting point, and we see other things down the road, but right now we're a SQL database primarily. So there's another layer in here which we'll talk about, which is what I'm calling a monolithic sorted map. And it's what's sort of logically underneath the transactional key value store. This is where the data in the database is distributed out to the various nodes, however big your cluster is. And finally, underneath there, we do replication. We break up that big monolithic sorted map into little smaller key ranges that are contiguous, and then those smaller ranges are what are replicated. We use Raft, which is a consensus algorithm to do that, and Raft is what's responsible for writing each one of the replicas to the lower level physical storage. So SQL. I think it's a pretty good question to ask why we're going for a relational SQL database. You know, especially given the last 10 years, people got really enthused about NoSQL and just like how it's going to solve all the problems. And actually, it turns out that NoSQL is in some ways kind of hitting a brick wall. I mean, there's still plenty of use cases for it, but relational databases and SQL in particular evolved over about the last 4 decades, and they're really, really good for building applications. There's a lot of tools for them. There's a ton of ORMs for them. So we're definitely leveraging that. There's a lot of people with knowledge of SQL, how it works, how to use it properly. I think one of the things that people, when they think about SQL,